Okay guys, we're here recording this. I'm going to talk real fast so I can keep this under 10 minutes, so pay attention. Alright, I've blown this up so it's large. Anyway, here we go. Roger Federer wins 61% of all his points that he plays. These are individual points, and we want to see if it gets to deuce whether he wins the game. Alright, so we talked about this in class, but I'm going to just go through it step by step. Step 1, you've got to define how you're getting your random numbers. We're going to use it in our calculator, so we just do rand int, okay? And just make sure you say 1, 100. This is whenever we have a percentage problem, alright? So anytime you see a probability given as a percent, use that. Step number 2, you've got to say what the numbers mean. And if we have numbers 1 through 61, he wins the point, and then make sure it's the point. And 62 through 100, he loses the point. And then step 3 is to define what a trial is. Well, a trial is playing the game. So trial, play game, and that's from deuce. Okay, so play from deuce. So that's where you pretend it's the score is tied at 3-3. You're going to press enter twice. So you're going to do enter 2 times. And so, for example, maybe right here, suppose we get like a 17 and then a 91, all right? What does that mean? Well, you've got your winning point and losing point. Here he wins the first point, but there he loses the second point, so it goes back to deuce. We talked about the scoring, so you should understand that. And then you keep playing, so then maybe it's a 22 and a 12. Well, on those 2 points, they're both under 62, so Federer wins, and that trial is over. So this equals Fed wins, right? That game wins the game, all right? So if you abbreviate and you sort of show the steps, it'll be pretty clear to me. You can assume that I know what these words mean, all right? So then step 4 is you just keep a tally of games won, right? Won and lost. And this is games, not points. So in this case, you go up here and you'd make a tally mark under he wins the game. And then figure out a percentage. Find percent probability of winning the game. All right? Okay? That's a difficult problem to do theoretically, but you could give it a try. Step number 2, a little bit more straightforward. We've got a classroom that consists of 25 students, 13 of them boys or 12 are girls. So for these first few, you can just read from the information, all right? If you've got a total of 25 students and 13 are boys, the probability of choosing a boy is 13 out of 25. And you can leave it like that, or you could write as a percentage, which I made easily by 25. That's just multiplying by 4, so that'd be 52%, okay? The probability of a girl and wearing a sweatshirt, then, well, if 10 students have sweatshirts and 6 of them are girls, that's just going to be 6 out of 25 total, all right? The word and means both things have to be true. It has to be a girl and has to be someone wearing a sweatshirt. And that's only going to be this 6 right here. Okay, for this probability with this line right here means that if we know the student is not wearing a sweatshirt, okay? Well, we've got 25 students and 10 of them are wearing sweatshirts, so we know that 15 total are not wearing sweatshirts, okay? How many boys are there if we've got a pool of 15 people that are not wearing sweatshirts? 10 students have sweatshirts and 6 of them are girls, so if 10 students do have sweatshirts and 6 are girls, then 4 are boys, okay? And if they're not wearing a sweatshirt, out of 4 boys that are wearing sweatshirt and 13 total boys, that means that there are 9 that are not wearing sweatshirts, okay? So from the pool that are not wearing sweatshirts, I've got 9 boys that are not wearing sweatshirts that I could choose out of that 15. So it's going to be 9 out of 15, or 9/15ths, okay? You can make a chart. It's a very easy way to go like this, and you just have your categories like this. and you've got, this is boys, this is girls, this is the total, this is wearing sweatshirts, this is not wearing sweatshirts, and you can just fill in your chart. You know that the sweatshirt wears, right, that's going to total a 10, so that's got to be 15 because here's the total of 25. You know that your sweatshirt wears, there's 6 of them that are girls. Whoops, I put this in the wrong column here. There's my total. And so that's going to give the 4 boys right here. Not wearing sweatshirts. Then there's going to be 9 and 6 to give us our 15. And then this totals down, as we'd expect, 12 girls and 13 boys. So you can see how to fill out that chart there. All right, what are the characteristics of a binomial experiment? I'm just going to read this. It takes too long for me to write it. But it's that there are 2 possible outcomes. Heads or tails on a coin, or true and false on a quiz, or rolling a 6 or not rolling a 6 on a die. They're independent. They do not influence each other. Tossing a coin once, you can pick it up and toss it again. There's no resulting influence there, so they're independent. There's a finite number of trials, and the probability doesn't change. It can't change throughout the experiment. Okay? An example would be, as I said, tossing coins. If you tossed 10 coins on the ground or tossed 1 coin 10 times, that would be a binomial experiment. Complementary events are events that together make up the total. All right? So there's an easy way to give an example. You could say, in a deck of cards, things that are aces of spades and things that are not aces of spades. You could say things that are face cards and things that are not face cards. That would be numbers ace through 10 or 1 through 10. Okay? So, but they have to make up all things. So complementary events are not, for instance, a 3 of hearts and a jack of diamonds. Those 2 cards together do not make up the entire deck of cards. Or even saying hearts and the black cards. Those 2 do not make up the whole deck. All right? Then this is a question that's similar to this one. It's just testing what your knowledge of this line here means. It means, what's the probability of choosing a Saturday if we know we're on a weekend day? Okay, and I would interpret weekend day to mean a Saturday or a Sunday. And the chance of choosing a Saturday out of those 2 days would be 1/2. Okay? So that's the first part of this practice test.